Hi guys, I'm going to go through the check for your understanding right now on section 5.1. Okay. Number 1, the probability of drawing a jack, queen, or king from a standard deck of playing cards is approximately 0.23. A. Explain what this probability means in context of drawing from a deck of cards. I'm going to be looking at a couple different things. I want to make sure that you don't say, well, the chance of getting a jack, queen, or king from a deck of cards when you draw a card is 0.23. That is not okay. You need to have a couple things. You need to say after many trials, or in the long run, or after several trials. Something about probability is over time. So you could say after many trials of pulling cards out of a deck, you will get a jack, queen, or king from a standard deck of playing cards about 0.23 or 23% of the time, period. B, does this mean if we repeatedly draw a card, replace it, shuffle it, and draw again 100 times, that we will draw a jack, queen, or king 23 times? No. Why? Because there's variation in statistics. We would expect it to be about 23 out of 100 times, but due to that variation, it could be a little more or a little less. That's what I'll be looking for, something to that sort. I will give you comments if it is not okay on your Schoology quiz. So please look at those comments. Now let's talk about number 2. This is the one where a lot of people said they need help. So I'm going to read through it right now. A popular airline knows that in general, 95% of individuals who purchase a ticket for a 10-seat commuter flight actually show up for the flight. In an effort to ensure a full flight, the airline sells 12 tickets for each flight. Design and carry out a simulation to estimate the probability the flight will be overbooked. That is, more passengers who show up than there are seats on the flight. That's my error there. I will fix that. Please forgive me. All right, so the first question, I have it all written down. I'm going to just talk about it. It's just the state. And this should hopefully be the easiest one for you. It's just rewording the question. And what's nice about this, it's redundant for some of you, but what's nice about it for a lot of you, it's making you stop and think, okay, what am I actually trying to figure out here? And I'm trying to figure out what's the probability that a flight will be overbooked. And I'm going to use simulation to get me there. So that's the state. So pause right now if you need to write that down if you need some help. Okay, next up, the plan part. This is where you want to label first. Always go to your percentages that they give you, okay? If they don't give you percentages, you're going to have to figure out the proportion. What proportion of the time? If you're struggling with this, please come in and sit with me. We'll go through several examples. I've had a handful of people do this already, and I think they've really gotten it by now. A popular airline knows that in general, 95% of individuals who purchase a ticket for a 10-seat commuter flight actually show up. So I'm going to use 100 digits, and 1 through 95 are going to be the individuals who show up. When you're dealing with percentages, you can always use it out of 100 to make it easy if you want. Okay? So 1 through 95, why 95? Because 95% of people show up. The rest, the 5% who don't show up, that's going to be my following numbers there, 96 to 100. That's 5 numbers out of 100 that represent the 5% of people who don't show up. So that's the first part of the plan. Now I'm going to walk you through sentence by sentence. Pause where you need to. Okay, first I'm going to talk about what am I going to use. Am I going to use a random number generator? Am I going to use a table? And we'll practice one with a table when we do a partner problem. But using a calculator, okay, because that's what you're going to use. That's the technology that you have. Using a calculator, I'm going to generate 12 random numbers that represent airline tickets. Why did I choose 12? I chose 12 because the airline sells 12 tickets for each flight, planning on a couple people won't show up. So I need to generate 12 tickets. That's the reason I chose 12. So that's the first sentence. Pause if you need to get it down or write down any questions you might have. Next, what did I put? 1 to 95. So this is where I ended from my last slide right here. Okay, 1 second. I ended right here on the last slide. Oh, I'm trying to this was my sentence from my last slide, right? Now I'm starting here at 1 to 95 represents someone who shows up. Repeats are okay because I'm dealing with percentages, that's fine. And the trial will end after I've generated 12 numbers. So you need to discuss how you're going to label people. You're going to discuss if repeats are okay. And you're going to discuss when the trial will end. It will end after I generate 12 numbers. Okay, continue. Here's where I'm starting now. I will repeat this process for 10, trials, and then find the proportion of flights that are overbooked. Why am I going to do 10 trials? Well, we really should be doing 50 trials, but I said in class, 50 trials is just too much for you guys to practice. Just practice this off of 10. There'll still be a little variation, but that's okay. So I will repeat this process for 10 trials and then find the proportion of flights that are overbooked. Why did I write that sentence, the proportion of flights that are overbooked? I'm looking how many flights are actually going to be overbooked. What's the probability that's going to happen? That's my question in my state. I always go back to that state question if you're curious, like, wait, where am I going with this problem? That's going to lead you. That's your framework for what's happening. All right. Next sentence, pause if you need anything. Okay, so I'm going to start here. That's where I left off with. In order to not be overbooked, two of my numbers must be between 96 to 100. So there I have in there the labels about 96 to 100. Okay, what am I going to grade you on? I need something about how you're going to use a calculator, how you're going to use a hat, how you're going to use a table, a dice, something that's random to generate random numbers. I need to know what the trial exists of, some sort of stopping rule, and I have that in here twice. I'm generating 12 numbers, right? And then I say, the trial will end after I generate 12 numbers. So I may be redundant, but I'm just trying to cover my bases. All right, next, I have my labels in here. I'm not going to judge you on this part. I'm only judging you on your writing. I shouldn't say judge. I'm sorry, grade you. Okay, I'm only grading you on your writing. I discuss repeats, and I talk about how many trials I'm going to do, and there should have been 10 trials, forgive me. And then what am I going to do? Then what? I always say, then what? Then I'm going to find the proportion of flights that are overbooked. This is answering your question. Okay, answering your question. Look at your notes. I have it outlined on the 5 things that I want. Okay, I have it outlined on the 5 things that I want. So again, look at your notes. If you're questioning still, come see me. All right, next I go and I need to start generating 12 numbers. So I have a screenshot now of my of my calculator. Random integer, and we talked about how to get there. If you need help, please see me after class. It doesn't take long. I put 1. Why 1? That's my first number. In the calculator, I don't need to worry about having the same amount of digits like I do on the table, which is nice. 100 is my last number. In our notes, I think we put our high number and our low number. So we said our first number was our low number, and our last number was our high number. Now you can't see the next part of my screen. This number right there, hopefully you're thinking, oh, that's 12. Why is that 12? That represents the 12 tickets. So each number you see here are my 12 tickets that are representing if the person showed up or did not show up. So you can see right away here, 98, that represents someone who didn't show up. 28 represents someone who did. 28, again, repeats are fine, represents someone who did. So on and so forth. And what I need to do is I need to do this 12 times in my calculator. And while I'm doing that then, I need to make a table. And here is my table. Yours is going to look different than mine. You can note I wrote down the trial of what happened of my 12 numbers. I crossed off 100. That means that person didn't show up. In order for the flight to not be overbooked, I need 2 numbers in this row to be between 96 and 100. I never got that. 100% of my 10 trials, which represents a flight, remember? So 10 flights were all overbooked. If you got to know somewhere, you just say, hey, how many overbooked out of your total? So on and so forth. If you need help with this, that's fine. But you are answering the question right now, right? You are answering the question, what's the probability of being overbooked? And you want to say, is it a likely event or is it unlikely? Is it likely that we're going to be overbooked or unlikely? Because we're answering that state question. Again, you can always go back to the state question. And now I'm going to do my conclusion. Answer that question based on our simulation. I'm going to be picky on this because this is based on our simulation. Just like in a court of law, they don't just say that person's guilty. They talk about based off the evidence, we believe the person's guilty. So based on our simulation, we can predict the airline will overbook about, I'm big on this word as well, 100% of the time. They may want to reconsider selling the extra tickets because most people are showing up, it seems like. All right, if you still have questions, now's the time to write an MRC pass for you or stay after or let me know and I will try to figure out other strategies to help you. Have a great night, everyone, and we will talk to you later.